Hey everyone, and welcome to This Explainer. Today, we're going to uncover how manipulating different frequencies shapes everything from beautiful art and mechanical robotics all the way to modern global security. It's an absolutely fascinating topic, so let's just dive right in.
So, picture this. A towering mountain range, a terrifying sci-fi monster, and a four-legged military robot. Kinda seems like they belong in completely different universes, right? But, as we'll discover today, these seemingly totally unrelated things are actually intimately connected. They're all bound together by one single thread, which is how humans interact with, control, and, well, are sometimes defeated by the physical spectrum of senses.
Here is our roadmap for the explainer today. We'll start off with the power of contrast, then explore visual extremes in capturing the dawn, move right into audio tension and noise, uncover the invisible electromagnetic battlefield, and wrap it all up with the future of frequencies.
Starting with Section 1, the power of contrast. Now, this concept is basically the core thematic glue holding all of our source material together today.
So, dynamic contrast. It isn't just some fancy term you'd hear thrown around in an art history class. It's the deliberate juxtaposition of strongly differing elements. We're talking about that razor-thin space between quiet and loud or light and dark. Whether your goal is to create a truly breathtaking piece of art, or, say, to completely dominate a modern battlefield, mastering this kind of contrast is the absolute key. It really all comes down to how you manage the extremes.
Let's move right into Section 2, Visuals, Capturing the Dawn, where we are going to start by exploring the visible spectrum. To really understand visual contrast, we have to look at some of the most extreme environments on Earth. Just imagine the dark, purple, starry skies of the Milky Way stacked up directly against stark, snow-covered rocks in Nepal. Or golden sunrise light piercing right through the clouds over Shimla. It honestly looks like a gateway to heaven. And then you have Mount Kanchenjugha in Sikkim, this massive physical terrain, suddenly struck by an incredibly intense orange tint right at dawn. This is light actively interacting with geology to create some seriously dramatic visual tension. And of course, there's the peak of Machapuchare.
Now, some visual wonders demand a totally different kind of respect. Machapuchare, which sits in the Annapurna Himal of north-central Nepal, is literally known as fishtail because of its unique shape. But what's really fascinating here is that its pristine visual contrast remains entirely untouched by humans. It's revered by the local population as deeply sacred to the god Shiva, and because of that, climbing it is strictly off-limits. It exists purely to be observed from a distance, a perfect visual contrast left totally undisturbed by our mechanics.
All right, moving to Section 3, Audio, Tension and Noise. This is where we shift gears away from the quiet serenity of visible light and plunge head first into the mechanical, high-stakes world of sound.
You know, there is a massive, massive difference between intentional and unintentional sound contrast. On one hand, you have the absolute brilliance of film composer Jerry Goldsmith. In the sci-fi classic Alien, Goldsmith masterfully used intentional dynamic contrast. Think quiet, creeping musical passages as characters sneak around the ship, suddenly followed by incredibly loud, aggressive attacks when the monster strikes. That contrast creates unbelievable emotional tension. But on the other hand, we have the exact opposite scenario. Boston Dynamics BigDog robot, which was a project funded by DARPA. For BigDog, sound contrast wasn't some clever tool for tension. It was a completely unintentional flaw that entirely ruined its stealth.
But before we get to its failure, we really have to acknowledge a staggering number. 340. BigDog was an absolute mechanical marvel. It was roughly the size of a small mule, and it possessed 50 different sensors measuring everything from joint acceleration to internal engine temperature. Using 4 legs with these incredibly advanced hydraulic actuators, it could actually carry 340 pounds of gear up a 35-degree incline. It could crawl, trot, and navigate rough terrain that wheeled vehicles simply couldn't even touch.
So, if we trace its timeline, BigDog started back in 2005 as a collaboration with Harvard University, aiming to be a mechanical pack mule for dismounted soldiers. By 2012, a militarized variant called the LS-3 successfully demonstrated a hike over incredibly rugged terrain. Honestly, it was a massive technological success in terms of engineering. Yet, literally just 1 year later, in late 2013, the entire project was discontinued and shelved. Why? Because of one single sensory flaw.
It is incredibly ironic. This brilliant rough-terrain robotic ninja was completely defeated by its own acoustic signature. See, it was powered by a small 2-stroke gas engine that produced 15 horsepower at a screaming 9,000 RPMs. Basically, it sounded like a roaring lawnmower in the middle of a quiet forest. The military deemed it simply too noisy for real-world combat, because that engine roar could be heard from hundreds of meters away. It just goes to show that in a tactical scenario, unintentional acoustic noise is a fatal vulnerability. You could build the most capable physical machine on the planet, but if you can't control your auditory contrast, you fail. Which brings us to Section 4, Invisible, the electromagnetic battlefield. We are now plunging into the chaotic, completely unseen world where manipulating invisible frequencies literally dictates the fate of modern nations.
Modern militaries have actually structured this invisible spectrum into a highly defined doctrine known as electronic warfare, or EW. In the information age, military dominance isn't just about physical force anymore. It's heavily about controlling the electromagnetic spectrum. It all boils down to three main pillars. First up, electronic attack. This is actively using electromagnetic energy to jam or spoof enemy systems. Then there's electronic protection, safeguarding your own tech using techniques like rapid frequency hopping. And third, electronic support, silently intercepting and geolocating enemy signals for intel. The very airwaves that power your everyday smartphone, GPS, are now high-stakes strategic battlegrounds.
So how is this actually applied out in the field? Well, disrupting these signals acts as a massive force multiplier. Militaries use EW to suppress enemy air defenses, essentially blinding their radar so aircraft can slip in safely. They can cause the total disruption of command communications, which completely severs a general from their troops. They can even spoof GPS, sending fake signals to mislead enemy navigation. Ultimately, this tech allows smaller or less advanced forces to level the playing field against vastly superior adversaries. It sets up a massive tactical advantage before a single physical shot is even fired.
The craziest part of all of this? The battle for the electromagnetic spectrum is 100% silent. Yet this silent contrast is just as powerful, if not way more powerful, than the visual awe of the Himalayas or the roaring audio of BigDog's engine. It can literally neutralize entire networked systems in the blink of an eye.
Let's move to our final section, number 5, the future of frequencies. Let's look ahead and see exactly where our mastery of this sensory spectrum is taking us next.
We are witnessing a seriously rapid evolution in military dominance. We started off in an era dominated purely by physical force, right? Tanks, missiles, kinetic energy. Then we evolved into the era of advanced mechanical engineering, pushing physical limits with robotics like BigDog. But today, and definitely moving into tomorrow, we're entering the era of cyber-electromagnetic convergence. This is a totally holistic, interconnected approach where hacking digital infrastructure and manipulating physical radio frequencies are deeply, deeply intertwined. To maintain this dominance, some incredible new technologies are emerging right now. Artificial intelligence is being used to automate signals analysis, creating real-time adaptive jamming that can literally shift tactics on the fly. Quantum technologies are paving the way for unhackable communications and insanely sensitive detection capabilities. And swarm systems are deploying vast networks of autonomous drones to conduct coordinated electronic attacks way faster than humanly possible. The invisible spectrum is becoming entirely automated.
Which leaves us with this final thought. We've explored the breathtaking visual light of the mountains, the physical roar of a mechanical engine, and the completely silent, invisible domain of the electromagnetic spectrum. As all these technologies become deeply integrated into the very fabric of our everyday lives, from the GPS in our cars to the data networks running our cities, we really have to ask ourselves, in a world where dominance is decided silently in the airwaves, is our absolute greatest vulnerability exactly what we cannot hear and cannot see? Thank you so much for joining me for this explainer, and I hope it leaves you curious to look a little closer at the invisible world all around you.